Yo, Chuck.
This video is going to be on binary search using recursion. Recall that binary search is just a way to search a sorted algorithm with a runtime of log of n. So it's pretty fast at finding a specific element that you specify or a target. So in this video, I'm going to show you how to do that using recursion. As always, we're going to make a function call. I'm going to say binary search. It's going to take an array, a starting index, an ending index, and a target. Recall that this array is going to be sorted for us already. Okay, so let's just console.log binary search and then pass in a sorted array. I'll use 1, 2, 3, 4, 5 and a starting index. We're going to start at index 0 and then we're going to go to 1, 2, 3, 4. So index 4. And let's say our target is going to be 5. This is going to be the value we're looking for, okay? So the first thing I want to do for this binary search function is because it is recursive, I need to establish a base case. A base case is a condition in your function that will prevent the recursive function from looping forever. So in this case, I'm going to use if the starting index is greater than the ending index, I want to return -1 or return some type of statement like, sorry, could not find the target. Basically letting the user know we could not find the value they're searching for. So this is like the worst case scenario, right? Otherwise, I will have found the target or I will need to adjust my indices. But before I do that, I want to establish a midpoint. So I'll say let mid equal start plus end, just like this. And then I'm going to divide that by 2 to make sure that the midpoint will always get the middle portion of my array, because this is just trying to find the middle index of my array. Okay, that's how binary search works. You look for the middle point of the array. If it's higher or lower, then you adjust your starting and ending indexes. But to make sure it's always a full-on integer and not a decimal number, I'm going to use the floor function built into JavaScript. Okay, so now we have a middle index, and if I return mid, I would expect it to be 0, 1, 2, so it would be this value of 2. Let's run that. It is. So if I was to call on array at mid, I should get 3, and I do. All right, so this is going to help us determine where our number is sorted in the array. So what I'm going to do first, best case scenario, if array at mid is equal to our target, we can return some type of message like, hey, found target on index at mid. Whatever mid is, that would be our index. Else if, so these next else ifs are pretty much the entire function that matters. This is the most, probably the crux of the whole thing. So I'm going to say else if array at mid is greater than target. So because we are searching for number 5, you know, during our first iteration call of binary search, our midpoint is 3, like I showed you before. But we're actually looking for number 5, and 5 is greater than our target. Or, sorry, array at mid is less than the target of 5. Okay, so I'll just do it like in this order. If array at mid, which is the number 3, is less than our target of 5, we need to do something with our starting index. So what I'm going to do is return the binary search function again. I'm going to pass in the array, the start, the end, and the target. But like I said, our array at mid, that number 3 is less than our target of 5. So I actually want to change our starting index to no longer look at all 5 numbers, but I actually just want to look at these 2 numbers. So what I can do is change our starting index to mid plus 1. And then now I need to do the inverse of that, else if array at mid is greater than our target. So let's say our target was a number like 1. And now we have array at mid during our first iteration of this binary search function is going to be 3, and it is greater than 1. So again, we're going to return binary search, pass in our array, our starting index, our ending index, and then our target. But this time, as you might have guessed, we need to manipulate our ending index so we're not looking at all 5 numbers again. We're only looking at these 2. So what we can do is take our midpoint and do mid minus 1. So this is our middle index minus 1, and now we're only looking at these 2 numbers. We're going to floor those numbers, those indexes, and then we're going to land on number one. So this is pretty much all you have to do for this algorithm. It's very simple. It's more of a conceptual thing, but you're basically just dividing your index depending on whether the array at mid is greater than or less than the target. So let's see if this actually works. I'll run it. I found 1 on index 0. What about if I'm looking for 5? I found 5 on index 4. And then let's do something to try and break it, like 99. Sorry, could not find 99. So this is basically the binary search function using recursion. It's not too bad. I think it's easier actually than the while loop version. I kind of like it better. If you found this tutorial valuable, please like and subscribe, and I will see you in the next one.